All right, we're going to start in 1 minute. 1 minute warning. Ready? Let's go. Good morning. Thank you, everybody, for arriving on time. Getting to Budapest. Welcome to Budapest. I need a clicker, which has gone missing. And then we'll be all set. Got it. All right. So, firstly, welcome, of course. This is actually our 21st Connect. I guess some people might say that we're now grown up, but I think we all still think of ourselves as a startup. This is actually the first European Connect for 5 years since Copenhagen in October 2012. With most of our members being in the US and in Asia, we spend a lot of time there. We've tended to do each other Connect in each continent, but it's really nice to be back in Europe. And it's very unusual for some of us from the UK not to be jet-lagged at Connect for a change. So also, as is traditional to this event, we'd like to welcome the new members who've joined Linaro since the last Connect. And the first one, I'm absolutely delighted to announce that Google has joined Linaro as a club member. Thank you. We've worked a long time with Google, really from the beginning of Linaro, on AOSP and on the Android platform, and we're delighted that given their support of open source in general, their use of open source, that Google is now supporting and working with Linaro. We'd also like to welcome 2 new members to the Linaro Enterprise Group. The Linaro Enterprise Group is now the largest group in Linaro. We have around 50 engineers, both Linaro employees, Linaro assignees, and a significant number of member engineers that bring the team to over 50. We are delighted to add to the list of LEG members Fujitsu, with their work on the Post-K supercomputer, which is using the ARM architecture, and HXT from China, which is a joint venture between Qualcomm and the China local government. So very pleased to have both Fujitsu and HXT joining Linaro. And finally, in the new member roster, we'd like to welcome Acer, who have joined Light to work on technology for IoT devices. So very pleased to have Acer as a member as well. All right, let's get to it. So our mission is leading collaboration in the ARM ecosystem. And there's a lot of good things that are happening at the moment. I think it is fair to say that open source software is changing the software world. And there's a growing understanding across the entire industry that all connected devices need secure and updatable software. And that the best secure software is open software. We're not going to establish global standards unless we build on top of open software. Also on the good side, for the first time ever, Linaro was the top company contributor to a Linux kernel release in 4.9. It already seems a long time ago, contributing over 10% of the changes as a result of some of the work that we did in Project Ara that was upstreamed in that release. Since then, in 4.10, we've reverted to our kind of normal position in the top 5 company contributors, but it was very nice to see Linaro for the first time being the biggest contributor. Congratulations to all of you. But it's not only the Linux kernel. Linaro and all of our members who are working in Linaro are contributing to a large number of different open source projects. It's across the ecosystem, ranging from projects that we've initiated, like OPTEE, and all the way to some of the biggest enterprise projects on the planet, including things like OpenStack. So ranging from IoT through mobile to enterprise, Linaro is contributing to a large number of open source projects across the ecosystem. But it's not all easy. Working in Linaro is difficult. It requires effort. Competitors don't naturally work easily together. Although sometimes when we come to these events, that doesn't seem true. These competitors who should be fighting hard against each other are working with each other, because that's what Linaro is about. But it's also difficult because open source is now completely global. Linaro is working across 24-hour time zones. Our members, our employees, working on projects, making a conference call with all of the necessary people who are interested in participating is very, very difficult. Somebody has to be up very early in the morning or very late at night. So this conference, where we get a chance to be together twice a year for a week, is really important. It's really important that we use this time together to work on what we have achieved and what we want to achieve over the next 6 months. But there are some tougher things going on in the industry. What we are doing, open source software, is disrupting existing business models. There are a lot of things that are going on that are causing disruptive changes in our industry. And one of the things I think Linaro needs to look at is, are we really doing enough to work out where we need to be? Because when we put software and work in the upstream, we're actually working at the bleeding edge of technology. A lot of the things that we do won't get into products for 2 or more years. And that's hard. It's hard to justify putting that effort in at this point, but even harder is working out where we should be in 2 years' time. And I challenge all of us to say, are we actually doing enough? Are we thinking about the right things? Innovation using open source is really hard, because by definition, you're making a decision that you don't want this to be proprietary. In order to be successful, it needs to be open. And that's very hard when you're working on new IP, new technology. And it needs collaboration. A single company can't take control anymore just by putting the effort in. We need to work together. And we need to recognize that we can influence individually, but we can't control. And it's about participating now, not waiting and see. If you wait and see, you'll be behind. If you participate now, you help set the direction. And finally, I think ARM is different. The innovation, the differentiation, what we are achieving, what the whole ARM partnership is achieving, is to bring new technology to market in different ways, much faster than on other architectures. And we now need to work out what is the ARM way of getting to where that puck needs to be. Not following the x86 way. What do we need to do that's different to take advantage of the differences that we have inherently in the ARM business model? And this is something that I think all of the steering committees should consider this week, of what are we trying to achieve and where do we want to get to? One of the things that is clear is that the days of traditional operating system platforms have gone. Platforms are by definition non-differentiating, and therefore people use them across the ecosystem. And if you look at the two biggest platforms at the moment, they're basically Linux and the Android open source project. Those two platforms are the biggest in the world, and they're both open source and they're both free. They're not free to build, they're free to use. And you don't get value from selling, you will not get value from selling embedded software on a per copy basis. It will be free. There will become a platform, just like Linux, just like AOSP, for the next era of IoT connected devices. And that will be open source software. Completely convinced. And the value that you will get will be from the innovation that you build on top of those platforms. So what is your value-added differentiating technology? What applications are you developing, and what are you doing with the data and the analytics of that data that you're gathering on top of these platforms? The platforms themselves will be open, and they cannot easily be monetized. They can't be monetized directly. So a couple of years ago, I talked about some difficult questions that we were always asked in Linaro. So this time I thought I'd try and dispel some myths. And the first one is that we're often told that Linaro is expensive compared to other industry efforts. And I would argue that Linaro isn't like other industry efforts. We're not about a single open source project. We reach across the entire ecosystem, and our model is unique. It's focused on engineering, on collaborative engineering. And when you join Linaro, you become part of an open source engineering team that costs over $50 million a year, over $40 million a year when you consider the Linaro resources and the assigned member resources. And this team is unequaled anywhere in the world in terms of knowledge of not only the ARM architecture itself, but all of the low-level technologies that we're working on day to day. And the goal of this team is to reduce non-differentiating engineering effort that you have to put in as a company, as a member, because you're doing it together. And we're creating those platforms that we're building our products on top of. And that should enable you to spend your own engineering resource more efficiently on your own value add and differentiation. You're also getting access to Linaro, to ARM, and other member engineers. You're working upstream on many, many projects that are relevant to your business and your industry. And Linaro gives you access to a wide range of technologies, from core SoC-based technology all the way up to applications level and enterprise, big enterprise software. And most importantly, we have the ability to strongly influence and work on the future of open source technology across the ecosystem. And all of the shared funding that you're putting into Linaro is used for collaborative engineering effort and to try and grow and continue to enable us to do more. The second myth is that Linaro is ARM only. We're not ARM only. We focus on the ARM architecture, but in open source terms, the ARM architecture is one of many. And Linaro works collaboratively in upstream projects across the industry. We are doing a lot of work that influences and affects, and we actually do engineering and testing and maintenance on other architectures. The kernel itself, ODP, DPDK, which we're working on, UEFI and ACPI, boot software, the Zephyr platform. And a lot of our CI and testing has to be done across multiple platforms, including Intel. So kernelci.org we'll talk about in a little bit later, but that's a key part of what we do cross-architecture. And if somebody wants to bring a project to Linaro for us to work on, then it doesn't matter that it's not only ARM. The next one's a little tricky because sometimes we're told that Linaro is not always inclusive enough of the community. and that we shouldn't have software that's member-only or member-first. On the other hand, we're told that Linaro doesn't give its members enough advantage and it should be member-first. So this is a little bit difficult to dispel, but I can only really tell you what we're doing. And what we're doing is we're focusing in the core business of Linaro, in our OCE division, which is 80% of what Linaro does, is working in the upstream for the benefit of our members and for the ARM ecosystem. And that is not successful unless you are open and working in the upstream and engaging with the upstream community. We also have a services division, and that is necessary because some of our members are working on proprietary products or their own technology, and it's not fair to use shared resources to focus on one member's technology. And so the services division does things like runs the landing teams, which work on member-specific products, and also is available for other projects, and one example was the work we did on Project ARA. So Linaro membership is about participation together in the open source tsunami that is sweeping our industry, and it's helping deliver these open platforms. And we can only do this together. You can't do it on your own. So how could Linaro help you to collaborate more? And I'm just going to give a couple of hypothetical examples. There are companies today that have to deliver embedded ARM hardware to hundreds of customers, and in order to get the benefit of ARM, they're working with multiple vendor Cortex-A SoCs. And they've built a partner, let's just suppose they have a partner ecosystem, and what that ecosystem does is it takes the vendor BSPs, and depending on the long-term support of the SoC, whatever it may be, these BSPs could range from being relatively recent, perhaps a year old in terms of the kernel, to 3 or more years old for a part that's being long-term supported. And what they end up doing is they end up creating a custom software build for every customer product. And they're getting very good at it. They take the SoC, they take a distribution, they take customer-specific hardware, they build the whole thing together and create a custom, an entire custom platform. So there's a better way of doing this. If you come and collaborate within Linaro, you can work on creating a unified software platform across your SoCs of choice and base that upstream and build in security and over-the-air capability into the platform once. Do it together. And then leverage your own partner ecosystem to deliver value-added services in the areas that can actually generate real return for you. And the result is far lower maintenance costs, faster time to market, and enabling a trusted hardware and software ecosystem around your products that works cross-SoC vendor. The second example is coming up more recently, where ARM enterprise activity is really accelerating. We can now get ARM servers off the shelf in the marketplace. And so companies are starting to get interested in what is the return if I invest in the ARM server ecosystem. And so a company might take 4 different enterprise distributions, and they might take 4 new enterprise SoC vendor platforms. And each vendor is delivering to that prospective customer a completely new system with the latest firmware, kernels because now upstream is working, distributions, and of course just a few things to last-minute additions just to make sure that the best possible foot forward is placed. In fact, some of those patches are identifying problems that have been noticed perhaps in the upstream kernel, and different vendors are independently addressing the same problem in a different way. So the company that's evaluating this now has 16 different software and system configurations. And as John Masters would say it should just work. And he's right. It should all just work. But it doesn't yet. It just doesn't yet. We've got to get to the place where it does. So one of the things that we want the enterprise group to talk about this week is how do we make this better? How do we collaborate to make this better? And maybe we build and use what we have in terms of infrastructure, some kind of common and agreed test platform that runs on every SoC vendor's hardware and includes a lot of testing and use cases and even customer test and use cases. And the results and the benchmarks out of that can be public or private, depending on each vendor. The result is a common baseline that everybody knows works. And this doesn't remove the relationship between the supplier, the SoC vendor, the service supplier, and the customer. It just adds to it. Let's build that common baseline together. Okay, switch topics and a quick tour around some of Linaro's technical activities. The core and club members invest a lot of resources in core technologies across Linaro. And just some examples that we've been thinking about in Linaro getting ready for this conference. In the kernel, there's a lot more interest in hard real-time activity because when you start thinking about 5G networks, the amount of data that's flying around, we need to have better real-time control in the Linux kernel. It's been over 20 years. We need to finish the job. And ARM can lead this. Think about what I said earlier. ARM needs to lead the industry in certain places. Maybe this is one. In power management, we need to move beyond the CPU core and think about the whole SoC. ARM SoCs are getting very complex. We're adding a lot of different cores, a lot of different accelerators, either on or off the SoC. We have to think about the whole system. Security. We have an open source, secure, trusted execution environment. Let's make it the one that everybody just uses by default. It's interesting, OPTE is actually getting a lot of activity across the industry. We're getting more and more inquiries. We need help, we need resources. We need to come together in the security area and work on a single open platform that then can be taken and people can then add their own proprietary requirements on top of. But if we don't have a common open platform, we're not doing ourselves a service. Virtualization. We're pretty much functionally at parity or close to parity with x86. What do we do next? What is needed in the ARM ecosystem? Where are the opportunities? And let's build that software. Tools, there's always work to do on tools. It astonishes me how difficult it is in the IoT space to move from one OS to another, or even from one SoC vendor to another using the same OS. The other end of the scale, GCC, was going to be here for a long time. I won't say always be here, but it's going to be here for a long time. But LLVM is increasingly being used for new technology. We need to improve ARM's LLVM performance. And finally, we really need to focus on automation and CI. The future of software and these big building platforms is about automating because it's the only way to scale development, validation, and ultimately certification. In the server space, working upstream is absolutely mandatory. It should be mandatory in all segments, but in the server space, you don't get to sell anything unless you're upstream. And ARM servers now just work, but that's not enough. We have to bring innovation and benefit. We have to deliver value to customers who are going to buy ARM servers. And maybe that's in high core counts. Maybe it's in lower power for a given workload. There are opportunities both in existing platforms, existing standard data center installations, and in new markets. The machine learning explosion across the entire industry is a big opportunity for ARM. What do we need to do to enable that in open source? And there's a lot of work as a result going on in some of the accelerator standards, so C6, Gen Z, and others, which are going to be explored this week. The key point about enterprise is that it's not just about enterprise. If you think about some of the architectures in enterprise, containers we'll talk about later, these are enablers. They're going to be used in other platforms. A gateway is essentially a small server. That's what it's going to become. Enterprise technology is going to come to IoT, smart devices, gateways, cars. So we need to be thinking about that as we build this software. In the networking space, Francois and the LNG group have been doing very good work and are continuing to work on dramatically improving the ROI of networking equipment and software. We're seeing significant IPsec gains over competing architectures, leveraging today's hardware accelerators. This isn't something in the future. It can be demonstrated today. And working on innovative network virtualization technologies this year and next. There are opportunities in customer premises equipment where if you're serving video streams, for example, 4K video streams to households, you can actually deliver a very large number of streams using thousands of VMs working on a single socket. How do we make that happen in the ARM architecture? And the cloud radio access network opportunity is how do we make it better, going back to the real-time kernel comment, how do we improve real-time performance and latency so we get guaranteed bandwidth when we go to very high network speeds? We're being slowed down in the networking area because the service providers are still resistant to using platforms as distributions, as opposed to building their own custom software. That's increasing the costs of development, deployment, and maintenance. Bringing out these open source technologies is going to dramatically improve the economics of networking equipment, and ARM stands to gain the most. In digital home, there are too many media standards. Accelerated media on ARM should just work, and today it requires a lot of effort. So building on FFmpeg and V4L2, the Digital Home Group is trying to enable complete open source reference secure implementations using OPTEE underneath commercial third-party DRMs. And so reference set-top open source solutions are available both with the Comcast RDK and also with Linaro's own Open SDK. And the goal here is to create best-in-class reference open source TV experiences, whether based on AOSP and Android or based on Linux, and leverage that unified accelerator media work and secure video path into AOSP, focusing on the high-end set-top platforms because it's going to be tough to compete with the $30 ones that don't do full DRM security. Mobile Group is our longest lasting it is where kind of Linaro started. And the focus in the mobile group this year is to collaborate with the kernel community to extend long-term support, particularly around the kernels that are used for AOSP and mobile phones. And this is important because we need to create a platform that's easier to update continuously. Continue trying to reduce the gap between the Android common kernel and the mainline Linux kernel. And this is an effort that Linaro's been involved with for several years now, and we've made a big impact. We need to continue that work. And we need to improve CI testing and validation. We need to catch regressions earlier. Light is our infant in terms of groups. We are focusing on embedded automotive, gateway, and IoT applications. And in the IoT space, we're coping with tens of real-time operating systems that have a significant market share. We're coping with middleware and network options that have exploded. We're coping with hundreds of different microcontrollers, microcontroller architectures, and then boards that have those microcontrollers on. All of them, we need secure over-the-air update, and we need secure sensor data connections to the cloud. We have to be able to update these. And so what Light is doing is it's looking at how to drive consolidation with a complete open source platform solution. How do we meet time to market with a new code base that's going at the speed of light in full development mode? On the IoT gateway, we're coping with different protocols, vendor lock-ins for every single gateway. You need a gateway for everything. We've talked about this before. And so why can't we as ARM lead the development of a flexible, unified, open source gateway solution and base that on core technology and then containers running the actual applications? So you can have multiple proprietary gateways in containers on a single hardware platform. Now, we need to ally across the industry. This is an example of where it's not ARM only. We need to make sure we build a platform for the industry, with the industry. So we are discussing with industry partners how we consolidate this across many ongoing gateway initiatives. And there will be discussions this week. Talk to Matt Locke if you need more information. So some of the key themes that we're going to be working on this week and this year, security is, of course, everywhere. In Cortex-A in Linux, Secure Linux, SecComp, which is used in Docker. In Zephyr, we're doing a lot of work on PKI security, basically open source implementation in software that then you can augment with the hardware accelerators or the hardware capabilities in your own SoC. The ARM v8M architecture is coming out this year, adds trust zone into the microcontroller space, and we do need to cater for these MCU-specific hardware capabilities because they're being delivered as value add by the MCU vendors. OPTE, I mentioned earlier, let's make it a secure, global, open source platform that everybody can use, and let's invest more into it. OTRP, Open Trust Protocol, is another forthcoming standard that's been published. We need an open source implementation. We can only do this together. We don't have enough resources to take 5 or 6 of our own engineers to do this. We need to work on these problems together. And ARM introduced the platform security architecture at the last Connect in Las Vegas. That is rolling out this year, and we need to make sure that's part of everything we do. The second theme I've mentioned, automated testing. There's this increasing requirement for connected products. You can't just test a product anymore during development. You have to enable security fixes, bug fixes, and optionally feature updates during a product lifetime. And so automated testing is becoming more and more important from everything from enterprise to IoT devices. Today, we have the kernelci.org effort, which was started by some of the Linaro team a while ago. Today, we're building and booting continuously 64 unique trees, 249 boards, 3 architectures, and 33 unique SoCs. But it's not enough. We're just building and booting. We're just doing a basic sanity test. We have to put more functional testing in, and that needs more resources. We need to virtualize this. We need to get it running in the cloud, and we need to have full functional testing, or at least a lot more functional testing across the kernel. We need to continuously integrate, continuously test, so that customers can continuously deploy. And we need to think hard in this group about how do we actually achieve this? Where do we put the physical resources? Because it's hard to work in China on equipment based in Europe, and vice versa. Another theme is the rise of containers. I think pretty much every software engineer has now heard of containers, and many of us are now using them. Software is globally deployed into virtual environments today in the enterprise, where it's instantiated and destroyed instantaneously. And this is revolutionizing the use and the management of the data center. Containers are actually an enabling technology for deploying software and for orchestrating. And applications can be run in containers. An enterprise distribution can be run in a container. And so there's a lot of effort going on and thinking going on and early technology deliveries from the distributions in terms of building a container platform. What is the firmware, the kernel, the minimal services you need that are lightweight with minimal secure attack surfaces and that is completely updatable, that then you can run all of this software on top of? And this is beyond just the data center. This is going to be the architecture. This architecture is going to get into home devices, factory devices, industrial, automotive. It's the clear way the industry is moving. Again, go back to what I said at the beginning. Where do we want to be in 2 years' time? We need to build this together. Another one. Linus mentioned this a little while ago. How do we get developers to work on ARM first? Why are we still using Intel tools, right? Where is the ARM box that leverages the cost down of the PC industry that can be used as a development machine or as a server? Where is the hyperscale box that a developer can have on their desk to do some interesting research and things? Maybe we could take a Chromebook design and just put more memory on, get good upstream Linux support onto it, and use it as a developer platform for developers to carry to conferences. Where's the ARM equivalent of the ARM NUC? So let's go and see if we can work on solving this problem. There's a session to gather requirements on Friday. If there's something that interests you, go and join it, put your ideas into it, and maybe we can leverage our connections, talk to some ODMs in the industry, and get some hardware out that we can use. And as servers get put in, more servers get put into the cloud, maybe we can actually start really making, for ARM developers, ARM the development tool. Okay, quick change to 96 boards. There's a lot of activity going on in this space, led by Dr. Yang Zhang, who's the head of our 96 boards effort. There are over 30 new processor boards in design that we expect to be delivered into the market this year across SoCs and MCUs. And there are a number of boards that are being shown at this event or being shown to a limited audience of developers at this event using the latest mobile technology. So latest mobile ARM processors, latest Mali technology. If you're interested in getting your hands on one of these to help get the software ready for launch, because we want to launch these boards in the next few months, then please go and talk to Yang and explain your interest to him. There are some boards that we can't announce today, but they're going to be announced very shortly. What I can announce today is that one of our China members, RDA, is building an IoT board with a Cortex-M4. Their MCU has Wi-Fi built in, including the Phi and Mac actually on the device. And then the board has flash, SRAM, and cache and crypto security hardware. Another board is from MediaTek. This is a new board with MediaTek MCU on that includes Wi-Fi and Bluetooth LE. And again, flash, SRAM, ROM, and crypto security hardware on the SoC. Both of these boards have had Zephyr ported to them already. And on the CE side, ArcherMind, you can today go and order from AliExpress.com an X20 Pro. This is the CE spec. It has a 10-core SoC with A72s and A53s and a Mali T880 GPU. You can also even put an LTE radio module on top of it. And that's available today. You can go and order one online. Finally, there's a new board that we were involved in the development of, which is 2Coding's mezzanine board. This is a sensor hub and is designed to be able to be plugged on to any of the CE boards or anything that meets the 1.8 volt expansion spec. And this has a range of sensors on, from accelerometer, gyro, magnetic pressure, ambient light sensor, proximity, microphone, temperature, humidity, and also has a number of LEDs on, and we're going to show you that a little bit later. Last time we were here, or last time at Vegas, hold on one moment. This is where I need to make sure that I'm logged in. Okay. We talked about a board that was being introduced by Orange Pi. This is built to the IoT specification and has a full ARM Cortex-A5 with integrated 1/4 gigabyte of SD RAM and 1/2 gigabyte of NAND flash. It also has micro SD and camera, and can of course be used as a pretty powerful vision processing either for robotics or drone applications, and has built-in Wi-Fi. I have one of those boards here today, and you should be able to see that board there. You can see as I am on the console, which is running Ubuntu, you can see the serial port flashing. If I just do a uname -A, we can see that it's running Ubuntu, ported by the Orange Pi guys. And if I do a PSX, we can see that it's actually running. So this is a board that is going to cost, it's going to cost $10. That's astonishing, to be able to actually have a board of this power, $10. Now imagine this tiny board here, which is this big, put on a sensor hub, and you've actually got a pretty good camera sensing drone all ready to go. So excited to see what the community is going to do with that. Okay, let's talk a little bit more about the embedded and IoT space. There are tens or hundreds of OSs out there. There is starting to become a standardization around the IoT protocols at the low level. So things like CoAP, LWM2M, AMQP, MQTT, these standards are now actually getting established as the future standards of the IoT. And then higher level libraries like IoTivity and Thread. The challenge is that each of these is being ported to every OS. Everybody's doing the same work on their own OS, again and again and again. And they're all starting with various pieces of code, all writing from scratch, and they're all different. And then each of those is being ported onto hundreds or even thousands of MCUs and SoCs. This is not sustainable. We're heading for a disaster here. You cannot do plugfests at this scale. We can't make sure the IoT is going to interoperate and work together if we do this. But this is what we're doing. So what can we do about it? Well, what we're trying to do in Linaro, with a small team, but we need you all to help, is that we're working on trying to create a platform for IoT innovation. And we're not trying to say there's only going to be one, but we need to work in one place so that we can test and configure and deliver open source technology to the entire ecosystem with a cross-industry, open governance, open architecture, Linux-type kernel model. So we're using the Zephyr project for that. And the fact that it's licensed under a permissive license enables proprietary innovation on top of this platform. And building in security and over-the-air updates from the outset is critical. And so then we need to support commercial industry, device management, and cloud platforms, because that's where the money is made. That's where the business is actually getting the data and using it. And whether it's a big platform like an Embed Cloud or a IBM Bluemix or an Alibaba or a Microsoft Azure, there are lots of them, or whether it's a private one that's being used for an industrial IoT application, we need to be able to connect devices to these clouds. So Light is focusing on delivering technology into the Zephyr project, working in the upstream and making those technologies and APIs available for reuse by other operating systems. But Zephyr is brand new. It's very fast moving. It's completely bleeding edge. Nobody would use it at first sight in a product today. How do we get this to market quickly? There are many use cases, sensors, controllers, light bulbs, industrial applications, measuring humidity in a farm. There are many use cases that can be met with a small set of functionality that you can bake quality into. And so there's a small Linaro team in the technologies group working on delivering end-to-end use cases for small applications that can be brought to market today. And the goal here is to accelerate product quality and adoption, reduce fragmentation, and get to market faster with next-generation open-source platform technology. So those members, and most of you here are connected to Linaro, and most of you are members, we do send out a monthly engineering report. And if you don't read it, you missed out this time, because quietly, a week or two ago, a couple of weeks ago, we actually provided the information on how to access the technology preview release for this IoT platform based on Zephyr. And that uses Hawkbit for open source Eclipse project Hawkbit as a development platform for giving us device management. It uses gateways built out of high keyboards, so trying to use what we have, and it uses a range of IoT devices. That technology preview release includes a basic stack that goes all the way up to HTTP based on upstream Zephyr, including an over-the-air updater and built-in security. And you can program it from an applications point of view in C, JavaScript, or Python. And you can go and download that code and replicate what we've done. Take a look at that. There is documentation. There's code for Hawkbit, for the high-key gateway, which is running a Debian stretch build, and then for Zephyr itself. And all of the information is at that URL. If you miss it, go and talk to Alan or Tyler or any of the team you see up here in a minute. But we thought we'd show you some of the things that we've been doing. And actually, in the last 2 weeks, we've been continuing. We've been making more progress, and we've been building on that technology preview release, still using Hawkbit as our kind of development environment for device management, but now starting to say, okay, how do we connect to commercial clouds, whether it's Embed, whether it's IBM Bluemix, Alibaba. And so we've started with MQTT and Bluemix, and we're going to show you this now in a demonstration. So I'm going to ask the team to come up, Milo, Tyler, and Ricardo. Okay, so Ricardo, why don't you tell us a little bit about what we're going to show here?
All right. Hello, everyone. So what we're going to demonstrate and what I'm showing actually here, here's the 96 boards, carbon boards that are all connected in here, and here's the nitrogen. And we have a set of gateways that are providing connectivity, and we also have a K64 wired over Ethernet. And here, one interesting thing as well here, like all the boards are connected through USB, but simply just to power the boards. All the communication is actually going wireless over Bluetooth. And all the data is being managed, as George said. We have the management system Hawkbit, which is managing all the devices, and then we also now integrated with Bluemix, which is receiving all the events from the device. And to show that part, I'm going to pass it over to Milo, which we're going to demonstrate.
Yeah. So what we have here is a web-based application that is built on top of the Bluemix APIs. This enables us to extract information from Bluemix. As you can see on the top left, we have the number of devices available. These 10 devices we have over here. The devices that we have online are reporting data, and the number of events or messages that Bluemix is sending our way. Here on the bottom, instead, we have the data that these devices are sending. In this case, we're interested in two values, two temperatures. The green line is the environment temperature, and the purple line is the CPU temperatures. In this case, you see a flat line because these boards are not reporting any CPU's temperatures at the moment.
So we're seeing here real-time IoT devices wirelessly connected through a gateway and up into the cloud running commercial Bluemix to access the sensor data. Oh, that's good stuff. But I talked a little bit earlier about maybe we'd like to show you the new Sensor Hub board. So what I'd like to do is ask Ricardo to take this number of sensor boards that we've just got from the manufacturing line in China and just, can you add it to the system, please?
Sure.
So show everybody what you're up to.
Right, so let me put the boards in here. What I'm going to see here is the sensor hub connected to the nitrogen boards that we have, which is compatible with the 440 pins. And I'm just going to put them online and see how they actually behave. All right. So, and I got one here just to kind of demonstrate quickly. So here's the sensor board. It got many different sensors and LEDs that can be used. And we basically just simply connected over the 40 pins header that is available on the nitrogen. You could also as well, for example, on a high key, connect that as well because it's also compatible with the 1.8 volt. And you can use both on these boards and those boards. And here in this case, we're just trying to explore those boards connected to the nitrogen boards that we have here. So we're just going to show up and pass it over to Milo again to see if the boards are actually reporting data ready to Bluemix.
No, they're not online yet.
Okay, so
wait a little bit.
Still waiting for them to arrive. So what's happening here is we're waiting for the cloud service to actually register the devices, right?
Yeah, exactly. When the board gets online, it reports the status, and they're actually connected. No, they're actually not connected over Bluetooth at this point. So there's probably a lot of interference surrounding here, so, but they should be connected over to those gauges. We can probably just power cycle quickly the gauges and see if there's any problem.
We did too many perfect run-throughs this morning.
It just worked.
Yeah.
Before. All right, so one of those devices are actually online now.
Yep.
Yeah, it did show up one in there.
Okay, here we go.
The other one is getting online as well. So
It's all these mobile phones in the audience, right?
All right, there you go. Words are showing up.
There we go.
All right, all the 5 in there. All right, you get in there.
So now we've got, you just plugged in these boards and they just appeared and we're now getting data into Bluemix from them just simply by plugging them in.
Exactly.
But I thought you promised me that there were going to be flashing lights and excitement.
Right. So here what we have is basically the same firmware that is running on those nitrogens here. So they don't actually have the capability of talking and understanding and actually exploring the sensor hub in there. So what we're going to do in here is basically update those boards and deliver a new software that can use the additional functionality provided by the sensor hub. And to do that, I'm going to pass it over to Tyler, which is going to drive the update process for us.
And so this is complete, they're wireless, right? You're not,
Yeah.
You haven't got any wires
No.
here. So you're just going to over the air update them and give me sensor hub functionality.
Exactly.
Okay. So Tyler.
Okay, so as Ricardo mentioned, we need to do a firmware over-the-air update to enable the sensor board. So we're going to do that now via Hawkbit. And we're going to select our build, which is going to enable the sensor hubs, and then we're going to select the nitrogens with the sensor hubs, and we're going to update all 5 of them at the same time. So we're going to save that rollout. Once it's ready to go, we will start the update. And the update started.
Okay, so we've now started a rollout over the cloud to a bunch of devices. It's going to take a little while, so I'm going to ask Ricardo, while that's happening, to actually talk a little bit more detail technically about what we're seeing here.
All right, so as we're just talking, all the devices are sending data to the cloud, and are connected to Bluemix. In this case, we're not showing the live data, but if you, on this same setup that you're able to reproduce by following the link that George just mentioned, you're going to see when you actually open the dashboard, all the devices are reporting the status to Bluemix. So you see high key with a different symbol in there, which is the IoT gateway, and all the nitrogen and carbons in this case, all kind of showing up in there as well. So you can control and manage and see all the data of the devices in the dashboard. And to talk a little bit more about the setup that we have, as we were just saying, all the connection here is wireless, using Bluetooth over, using 6LoWPAN over Bluetooth. So we have IP connectivity across all of these devices. The high key is providing the gateway capability by simply allowing those devices which are Bluetooth capable to actually have an IP and talk to the cloud. And one interesting piece that we have on the gateway is that Bluemix doesn't yet support IPv6. We have an IPv6 based network in here. And we have basically tiny proxy just to convert from IPv6 to IPv4 so it can still be compatible when the IPv4 set up. And then we have, once they're all connected, they're managed by the Hawkbit management server and sending all the data to the cloud. And one interesting point in here is that, as George mentioned, everything is like close to tip. The Zephyr build that we have is version 1.7 RC3. The high key is running Debian Stretch and the 4.9 kernel, so everything that we have is really close to what we currently have on the upstream branches of those projects. And to talk a little bit how we actually did all this integration with all these different projects. For example, the Zephyr, we have not only Zephyr, but we have our own application. We also have the bootloader, which is capable of doing the system A/B partitioning. When our application fetches the new application, is write it up on the second partition, rebooting and doing all the update and so on. So there's several projects that are involved in here. So what I'm going to basically ask Tyler to explain to us is how we did manage the development of all those projects to actually have this demo in here.
Thanks, Ricardo. So as George mentioned, we're basing this application on Zephyr 1.7 RC3, so it's very, very close to upstream. And to do that, we need to leverage CI and automation as much as possible. So let's talk about the sources that we have to track. We have to track the Zephyr tree itself, because this is an out-of-tree application. And there's the master branch, which is upstream. We have 2 branches that we track with our patches that go upstream. So we need to test those as well. And as Ricardo mentioned, we have MCU boot project, which cryptographically validates the images that we send over the air. So we need to be able to track upstream and our own branches with our own patches. And then, of course, the application itself. So to do that, it generates quite a large matrix of things to test. And we do builds on every single one of those permutations. We test on real devices on every single one of those permutations. And we do end-to-end rollouts, as you're seeing here, on every single one of those permutations. All of our development is done in GitHub. So we've integrated all of our CI services to work with the developer workflow in GitHub. So we test pull requests as they come in. So we can't check in code that doesn't pass check patch. A build test actually deploys to a device. So we have that capability. And once everything's merged, we actually run sanity check across all the upstream trees. And this enables us to be able to know if something breaks upstream or we break something that's upstream, so that we're very mindful of that and we can fix the problem quickly. So this is an example of one of our build matrices. So this is just for the photo application. So we're tracking 3 branches here. And what this shows us, this is actually embedded in our README GitHub Markdown on our project that you can find on the documentation website, that our carbon isn't building upstream. So we know that there's a problem, and we know that it's early, and we can get a fix in for it. So in addition to this matrix, we have ones for MCU boot for the Zephyr tree itself so that we can track all of those different permutations and make sure the platform support not only functions, but our application still functions. And as George mentioned, Zephyr's a very, very fast-moving project. So it's very, very important to have this automation so that you can continue to rebase on the latest master and make sure that there's no regressions at all.
Okay, so what's going on with the lights? We seem to have a number of devices updated.
All right, so as you can see, of course, we have the spinning wheel. The additional LEDs are being used by the application. And the one interesting thing that we can show you now is that not only the LEDs that are spinning in here, but actually getting data out of those boards. And so they should be now sending new data to the dashboard.
Unfortunately, we're running out of time, so we're going to have to probably not wait for that last device, but let's see what's actually happening here. So we've got a number of new devices come online, including the new ones which have both temperature sensors running, right?
Right.
So we've successfully over-the-air updated, and they're starting to transmit data in real time. But this is a temperature sensor, right?
Yeah.
So let's just make sure that we're actually seeing this in real time. I don't suppose anybody in the audience has a hairdryer. Marty, another one of the team, come up and just exercise our boards.
All right.
Is that not the one that's sent?
Maybe that one hasn't reported yet. Oh, there's another one coming up. There it goes.
Oh, there it goes. That's good.
Thanks very much, guys. Well done. We'll just leave that running and wait for the other ones to update. Thanks very much. Congratulations.
Thank you.
So what we've just done is we've taken an upstream release candidate that was only released a couple of days ago. We're running it on multiple different vendor MCU boards. We've got a unified secure boot and photo update mechanism, and we're doing real-time IoT device data transfers on all of these devices to the commercial IBM Bluemix cloud. And we're only just beginning, right? This is a preview. We're not yet at 1.0. This is something that we're going to be continuing to work on over the coming months. And even this week, we're going to expect to make a lot of progress and come back on Friday to Demo Friday. And this team are going to have a lot more devices and a lot more boards and a lot more scale. So looking forward to seeing that. What's next here is that this preview code release that I talked about earlier is available now. But we're also working on actually making this product ready. A lot more CI, a lot more testing, a lot more scale, but we want to make it suitable for a number of products that have constrained functionality as quickly as possible. So we're working on both larger footprint that you saw in the original technology preview with a full TCP stack and HTTP communications to the cloud, but also to lower power, smaller footprint devices and working with early users on a constrained stack using UDP-only CoAP and LWM2M to talk to clouds like Embed Cloud or proprietary clouds or IBM Bluemix and so on. And that will have Bluetooth, Wi-Fi, and LoRa support, and many more devices and vendors. We're seeing a lot of interest in what we're doing in Light and in this project. And it's important that we make this available to all cloud providers. So use a common cloud platform API so that it's easy to add to your own proprietary or commercial cloud of choice. So I've covered an awful lot today. I've only run over slightly. I'm going to ask Joe Bates to come and talk a little bit more about the week, but thank you very much for listening, and looking forward to the week. Thank you.